Alright, so in this part I'm going to be talking about naming ionic compounds. Just like with the covalent compounds, I'm going to start by giving a rough definition of what an ionic compound is. So an ionic compound is usually a metal and a nonmetal bonding together. Now what happens in this case is the metal gives up its electrons and the nonmetal takes the electrons. So this creates a charge imbalance that between the metal and the nonmetal that causes them to bind together or bond. So in this case, we call the metals, since they lose electrons, they become positive, and we call positive ions cations. Now, the nonmetals gain electrons, so we call them anions. Anion means negative ion, cation means positive ion. So just keep that in mind throughout the video. Okay, now that we have defined what an ionic compound is, roughly, we'll talk about the rules for naming them. So first off, just like in the previous covalent compounds, you read it from left to right. You start with the first element. In this case, though, the first element is always the metal. So, because the metal comes first, we list the metal name first. Now, and you don't need to change the metal name or anything, you just write it down as is. So if you have iron, you just write down iron. If you have magnesium, you just write down magnesium. You don't need to change that. Now, if the metal can have multiple charges, then what you do is you put the charge of the metal, in this case, inside of parentheses as Roman numerals. So what I mean by that is, let's say you have iron. Okay, iron can have a positive 2 charge or a positive 3 charge. Now, in order for anyone who is reading your work, for example, if they were to see that and they saw just iron in the name of a compound, they'd want to know which type of iron, which type of ionized iron are we working with. So what you do is you have to write down in parentheses and Roman numerals that in this case it's a positive 2 charge, for example. So that's how you deal with the metal. Then the second part is dealing with the nonmetal, the anion. Now, there are two different types, monoatomic and polyatomic. Mono just means one, so a monoatomic anion is just a fancy way of saying it's a negative ion that only has one atom. Monoatomic, one atom, anion, negative ion. Polyatomic ion means, poly just means multiple, so multiple atom, and then I didn't write an here, but negative ion. That's all it means. So monoatomic anions are given the IDE suffix. So let's go through an example for this. Let's say we had sulfur, which we know based on its location on the periodic table that it is S2 minus. When we ionize it, it goes from sulfur to sulfide. So that's all that first bit means, is you just put the IDE suffix. Now, as for that second bit, polyatomic ions, they just keep their name. Right, so what I mean by that is you should be given out a table. There should either be a table in your book with a list of polyatomic ions, or maybe your professor gives out a table. A friend of mine actually let me borrow hers for the sake of this video. You see that it's just a list of a bunch of polyatomic ions and their chemical formulas. So you should have something like this for your own use. And I would definitely keep it handy when you're naming compounds, so that way you can quickly refer to it, unless you have them all memorized already, which would be very impressive. Now, so that's the gist of the rules. This alone would get you through pretty much all of the problems regarding ionic compounds, but there is something that, if you haven't memorized them all yet, will help you remember the polyatomic ions with oxygens in them. So for example, like this and that and that, you see that you have something that would normally be a negative ion, and it has oxygen next to it. So this is all one big ion. And so is that, and so are these. So there's a pattern to the ones with oxygens in them. As the number of oxygens increases, the prefixes and suffixes follow this pattern. Right? So let's say that you knew that this was chlorate. So ClO3 minus is chlorate. You know that. You memorize that one. Then you could know ClO4 minus is perchlorate, because you see it's one more oxygen than the previous one. Then you can know ClO2 minus is chlorite, and ClO minus is hypochlorite. So basically the point I'm making here is, if you know one of these, you can figure out the other three with this pattern. Now I also wrote down sulfate and sulfite here. And the reason I did that is because I wanted you to realize it's not like this is persulfate just because it has 4 oxygens in it. It doesn't necessarily mean this is 4, this is 3, this is 2, this is 1. In the case of this right here, it's actually different. This is just sulfate, SO4 2 minus, and that is sulfite, SO3 2 minus. So just keep in mind that if you have a different element, like in this case it's chlorine, and in this case it's sulfur, they're not necessarily going to follow the same, they're not necessarily going to follow the exact same pattern, but they will still use this. Okay, so now that we've gotten that out of the way, let's go through some examples. So let's say we were given this compound right here, and we were told to name it, right? So we have an iron and 3 chlorines. Now remember, first rule, start with the metal. Right? This is just iron. Now, if you pay close attention, you should realize that there is a transition metal, though. And most transition metals do not have a set charge. They have multiple possible charges. So what we need to do is we're going to need to write that charge in parentheses. So what do you think that charge is? Right, so this here is chlorine. Ionized chlorine has a -1 charge each, and there are 3 of them. So that means we have a total charge of -3 from the chlorines. In order to balance this out to 0, we got to have a +3 charge from the iron. So that means that this has to be iron 3. And then chlorine, when you have a monoatomic ion, it goes from chlorine to chloride. So this is just iron chloride. Okay? Now you have this right here, MgC2H3O2, 2. Okay, so here we have magnesium, and you can tell based on where it is on the periodic table, right, that it has a charge of +2. Right? It's not a transition metal, it's an alkaline earth metal, which is just a fancy way of saying it's in the second column of the periodic table. So This is in the second column of the periodic table. If you look at the periodic table, meaning that that has a positive 2 charge, always. So we don't need to write down its charge when we write down its name. We just write down magnesium. So if it has a set charge, it won't change, then you don't need the charge in parentheses. Now this right here, don't be scared by its size. This is called, if you take a look at your chart of polyatomic ions, this is called acetate. So we'll just write down the name acetate. And I want you to realize something very important that distinguishes this from the previous discussion on covalent compounds. And that is that there's not really a counting system when it comes to ionic compounds. You don't need to count up how many of each type you have. So even though I had 2 of them, I don't need to write out diacetate. In fact, if you do write it out, that's actually the wrong name for it. And the reason being is because ionic compounds always have the same charges that you're working with. So if you have FeCl3, that's always going to be a positive 3 iron and negative 1 chlorine. So what that means is because you want these suffixes, not suffixes, these subscripts to be as reduced as possible, as small as possible, then this only has one possible implication, which is this right here. So just one name pairs with one thing here. So you don't need to add the additional challenges of counting up things. You can just say this is magnesium, that's acetate, and then you're done. So there's no counting system when it comes to ionic compounds. Now, there's only one last example that I have. Let's say that instead of being given the compound, we were given the name and we want to figure out what the compound is. So, if we were given sodium, not chlorate, carbonate, my bad. If we were given sodium carbonate, how would we name this? How would we write out its chemical formula? Right, so first thing we want to realize, sodium on the periodic table, again, that is in the first column, which means it's an alkali metal. Now the first column has a positive 1 charge. Carbonate, that right there is a polyatomic ion, if you take a look at a polyatomic ion chart. And what that polyatomic ion looks like, CO3, is this right here. You have 1 carbon, 3 oxygens, and a negative 2 charge. So, we want these charges to balance out. This is a negative 2 charge, that's a positive 1 charge. So if we just have 2 sodiums, that's going to be positive 2 with the negative 2, which gives us 0. So that means overall we're going to end up with Na2CO3. And that would be what sodium carbonate looks like. Now, that's basically the gist of naming ionic compounds.